These last few years, I've been working on a concept, which I will present to you here, which basically concentrates on how we harvest the energy. Previous speakers mentioned the problems of what to do with this energy, problems that arise because of this energy, and I present here also solutions, because this is at the end the most important thing. And at the end, there is no one simple solution. You have to design a solution depending on the requirement. So for sure, one of the biggest problems is that we are running into a scenario where sometimes we hear that our energy will increase or will decrease. We sometimes are happy when it is going to decrease, and we are sad when it's going to increase. And at the end, we have to find, again, solutions. One of the problems that surely is coming to us, whether it's next year, 5 years, 10 years, 20 years, is that the resource the oil resource is decreasing. The gas resource is being used extensively. So unless we agree as a population now, not Maltese, not Germans, not Italians, as a population, to agree to commit ourselves to at least a small percentage, for example, Malta is only 10%, we are only heading, maybe our next generations, into big problems. And this is very clear from studies that were done, and it is clear that we will have problems. Now, during the period of time, one might say, well, the problem is solved. Somebody cracked the solution of how to extract gas or how to find a new oil well, okay? But at the end, we have the sun shining on us, full of energy, especially in Malta, okay? And we can harvest this, and there is a lot of energy in it. Okay, and this has been proven through our work. I've been working on renewables and solar energy since 1992. Okay, and I've done a lot. One of the things that I've done is introduce the law here in Malta, because before you couldn't even connect to the grid, and this was important. We create laws that allow us to use this energy. Okay, one of the things. No, still there. There are advantages of these renewable sources, which usually are not mentioned by accountants. So we are only comparing costs, payback periods, but the reality, how rich are you when you lose the electricity or the grid? And what does that mean to you or your business? Okay? One of the important things, for example, in Malta, is that the peak happens in summer, as I will show. Okay? And this costs us much more than what we pay. What we pay is the average. But sometimes it is 18 cents, sometimes it's even 30 cents. And the advantage of, for example, renewables, some of the renewables like PV, is that this peak coincides when the electricity is the most expensive. One of the solutions is decentralized energy. We are used to depend on a power station. But in my concept here, which I will present, I'm going to present a scenario where I will not become dependent on politicians. I will not become dependent on power stations. I'm my own consumer and supplier. And that has shown to be the ideal scenario. Because at the end, you need power lines, you need cables, and the complete mix in your bill is composed of all this. So I've studied all the islands on the globe, and they all suffer from our same problem, the vulnerability of oil. Yeah? Every island runs from oil or gas. And this is becoming more and more expensive, as we will see. Tariffs has always increased. If we remember our tariff in the past, we used to pay 6 euro cents. Today, we pay 18 euro cents, okay, with the hope that we find some technology which makes the power station a bit efficient, okay, and maybe the cost comes again down. But this is only for a short period of time. At the end, the price will go up again, as we have seen over, as I will show later, please. Again, this I have explained. Here, as we see here, for example, this graph shows the rate of increase, okay, of the cost of fuel. And there is a constant trend of 8%. Obviously, around 2007 and 8, we had this big shock where we had a shoot up in the price of the barrel of oil. Okay, but the line shows that there is a constant increase. If you go, whether you use heavy oil, light fuel oil, the increase is the same because nobody is going to base his business, okay, of producing oil or producing gas. When I am a gas producer or you are an oil producer, we have to compete and we have to keep the margins close together. So I don't expect that somebody will give me something for free, especially if it has some advantages. The problem is, and that is what we are going to see in the near future, we already are seeing some signs here, that while the price of oil or non-renewable sources is going up, the price of other sources, like, for example, in the last few years, PVs, is going down. And at one time, there I made here a joke here, some will say, bingo, it's good, yeah? Now I don't need to pay any more bills. And it's happening in Malta. We are talking to people who have 0 bills. It's possible, okay? But others will say bank. The oil industry will say bank. No, this is not acceptable because I need to sell my oil. So we are already seeing these turbulences. And in fact, as we speak today, the European Union is going to take decision whether to introduce what they called anti-dumping tax on PVs, which in my opinion is a ridiculous thing to even talk about, okay? Because this is like when we used to believe that we can make clothes, but this industry went to China. Now, we are claiming that China is dumping, okay, dumping dumping the work that is required to produce a PV panel, like it was when you were producing a cloth or a piece of garment, okay? Now, the situation is this, that some time ago, the tariffs were such that if you want to install a PV, you wanted a special tariff. And the tariffs, we are talking only a few years ago, 5 years ago, were 50 euro cents, not 18 euro cents, 50 euro cents. Now we are talking that the bingo or bang is happening at 18 euro cents, which is the price we are paying at the moment for electricity produced from oil. So we reached that point. I have no doubt we reached that point. And these are reactions of the oil industry keeping us from develop this technology into, this is the conference is about Enerscapes, and I expect, for example, a bit more architects here, because one of the things, the biggest problems when, in order to create that scenario that, for example, PVs will really be integrated in our building in a big way, all right, it's still not there, and we have to make sure that this is coming. It is coming because at the end, if I have a holistic solution in a house, I can also use the PV panels to provide the shade and reduce my air conditioning bills. So the solution is not just putting PVs, as the previous speaker said, on my roof. I have to integrate them in an intelligent way, okay? Now the situation is this, that if I have excess energy, can I use this excess energy? The previous speaker said that this energy is so much during the day, but I have nothing during the night. Yeah? And when we talk, do we have energy storage? Of course we have energy storage. We have batteries, we have lithium batteries, we have lead-acid batteries, we have all the technology you can imagine. But when you come talk about batteries, it's a big problem, yeah? Where do I put them? And my issue is, yes, you can put them because you might be surprised what size you need of battery if you design the system properly, all right? But till now, the battery has been in a situation, or energy storage, where I'm there to help when I lose the electricity, or I'm there to help I have no grid supply. So I put a battery and I have some light. Now here in this presentation, I will turn the thing around, yeah? I will put the grid as standby, yeah? And I have my own system. Not everybody will like this, but it can be done, it can be engineered, and it is possible, and it is financially viable. And this is the issue now coming up. Before, we used to say, if you need electricity, you have to apply, for example, in Malta to Malta, you receive a bill of maybe 50,000 euros to get 3 poles and a line. Now, today, with 50,000 euros, you forget about this. You just put a few batteries, you put some PV panels, you put a generator just for standby, and you have all the electricity you need. But what is the size of battery, and what do we need to support this? I'm also a member of EUROBAT, European Battery Committee, which is set particularly at the moment. We are writing 3 white papers, one on batteries for cars, one on batteries for rural electrification, and one for batteries on smart grids. Okay? Here, in order to be able to talk and do this presentation, you have to work, you have to do something, you have to analyze. And what we have done on this company, we have done all the technologies you can imagine. Rotating the PVs, thin film, polycrystalline, monocrystalline. And we got the real results, what are expected here in Malta. Okay? Should I put them at 20? Should I put them at 25? Should I put them at 30? If I put them at 25, what do I really lose? And all the results here I presented in last year I presented another paper at Enerscapes, so I presented a lot of results, but anybody who wants some of these results, I have them. And here you see 4 years of continuous generation. So here you see winter, spring, summer, yeah? And you see continuously and repetitively the consistency of the energy you can get from the PV system. So it's not something like, for example, if I can bring in the wind, you might have wind or you might not have. No, this is 1 year after the other, very consistent, very easily to calculate. Okay? If we see what happened in Malta, this is 27 years now I studied what happened in Malta and the power station. And these are the blue line, okay? The blue paragraph is the energy, all right? The energy in winter over that year. And the yellow is in summer. And as we can see, in winter, before, our demand was much higher. Why? Because everybody was putting heaters. Nobody could buy air conditioners at that time, okay? But what happened? In the last few years, this changed completely. Why? First of all, there is the dip because of the recession of the last few years, 9 and 10, 2009, 2010 in Malta. But plus that, there is the energy efficient measures, okay? The PV coming in, and as well heat pumps, which are the air conditioners. Here, the comment is that you don't switch the air conditioner because they waste a lot of energy. In winter, they are the cheapest way to heat your house, the air conditioners now, here in Malta. And that is why the peak shifted from winter to summer. If we see what we have done is we took this system, which we have on this company, and I extrapolated, now not what the EU says, not what the 10% or what I say, what is the ideal for Malta? And one of the problems is that if you see the amount of energy during the summer days, okay, we have a big peak. This is the blue curve, okay? So between, say, 10 and 1 o'clock, we have a huge peak for which we have to switch on very inefficient, very costly turbines, which are the open cycle turbines, okay? And during that peak, my solar, as you saw in the previous slide, generates the most. So unlike other countries, for example, in Germany, this is not the same like we have here. They have it differently. Their peak does not coincide with the peak of the solar energy, but here in Malta we have this. We are lucky because of the weather we have. So what we did is we took all this PV system and I extrapolated what I would require if I had to kill that peak. And this came to 65 megawatt peak, which means that in the middle of summer, because of the high temperature of the panels, this will mean 50 megawatt continuous. And here you will see this is the light green is the energy from the 65 megawatt peak. I subtract it from the blue, which is the real energy requirement, and I get a very nice flat line. And this I did for 4 years. and it's consistently like that every day during the summer period. Okay? The next what I did is, obviously, I believe in solar, and I think it is a solution, a very good solution, that I myself, together with a group of other people, installed one on our roof and studied the family demand and what the PV will give us. This is, for example, the roof of my house. I made a very nice terrace, wooden terrace, as you can see, and there are the PV, and I'm grid connected. Okay? And as you can see here, this is the amount of energy. This is winter, this is spring, summer, and autumn. Okay? And during the spring, summer, this is the 100%. Here I'm 100%. So you can see, with only 12 panels, we are 6 people in the house, okay? With only 12 panels, which can hardly be seen. They are integrated so nicely on a nice terrace that you can hardly see them from the road. And if you look at it, it's a nice thing to look at, because this is another important thing, especially in this conference. I expected a lot of much more architects around, okay? Because this is one of the things, the design. I cannot expect that I do an eyesore because I need to go renewable. I don't expect that I switch off the air conditioning because I want to go renewable. No, I'm saying we can put everything together and we live a better life. That is what I'm after. Yeah? I have to live a better life and I have to use the technology. Okay? This here is the average. And as you can see, over a year, I'm around about 85% on average. But seasonally, I went even to 180%. So can I take a little bit of this energy and put it here and shift? Okay? Yes, you can, but you need storage. Okay? I drive an electric car, and I have storage. It is a battery in the car. But when I'm at home, that is when I want to use my energy. Can I charge the car with the PV panels? Yes, of course, you can charge. Can I put this energy in the car and then use it in the evening? Yes, of course. But they don't do it because they want to make business. They want you to buy a car. They want you to buy the PV. They want you to buy the battery. And you cannot mix, because otherwise you won't sell 2 batteries. You sell 1 battery. Okay? But the technology is possible, because I have 9 kilowatt-hour, as much as I require for heating in winter, in the car. And then when I need the heating, the car is in the garage. Okay? Now, most of the systems we have installed so far in Malta are grid connected. Why? Because the grid is everywhere. And you don't think of using a battery. Okay? But one thing, for example, we don't take notice of, that if I lose the grid, if the grid, there is a power cut from Malta, for example, in Malta, I have nothing. I cannot even power my fridge. So, can I do something? Of course you can do something. If I connect the car battery to the PV panels, I don't need an Malta. It's a matter of how to engineer the whole thing together. Okay? One of the biggest problems, and that is why we need energy storage, this is something will come. It came in other countries. They studied it. They analyzed it. Are we going to wait for that problem to come to Malta to do something? No. We have it. Others experienced it. We just have to engineer it. Okay? What is the problem? The problem is, as Charles Youssef mentioned before, you cannot just install whatever your roof takes. Yeah? You have to be careful, because if everybody is dumping the energy on this line, which is taking the power to every house, energy cannot be created nor destroyed. If there is too much energy, because it's summer, what will happen? Something will break. Or, in this case, the inverter will switch off. The payback period and what you calculate when you go to these sellers, as Charles Youssef said, they don't put this in the formula. So here you see a system installed in Malta where there is a lot of PV systems injecting into the grid, because unfortunately, and there I have to criticize, okay, the way the law was manipulated then by the even regulators was wrong, because everybody is saying, please generate what you have to use. Don't exaggerate. Okay? No, here we did it the other way around. We are giving 25 or 22 so that we excite the people, okay, that they do it, and dump it onto the grid. I think the worst thing we have to teach our generations is to dump things outside. Yeah? although sometimes we do it, everybody sweeps his dirt next to the next door neighbor, hoping that the next door neighbor will pick it up and put it in the bin. The same with the electricity. We have to be careful what we are doing. And here is a scenario where the output should have been deducted, but reality is this. And what happened there? What happened there is that there was too much energy coming into the grid. The voltage went up, the inverter went off. Okay? And you can have the payback period from 5 years then to 20 years, which is not something your accountant or your financial advisor will advise. Yes? So there are a number of scenarios where we might need energy storage. And the scenarios here, for example, in Malta, for those who are not local, is that we have two different tariffs. In fact, somebody told me that some foreigner took the regulator, Maltese regulator, to court. Because if you have, for example, a small house and you are a foreigner here, there are two tariffs. And this is, for example, the tariff for those who are non-residents, those who don't have an ID card. And they pay, if they exceed 20,000 kilowatt hours, which if you have a small, a decent house with air conditioning, is possible if you come here regularly for your holiday, you pay up to 70 euro cents per unit. Now it's not 18 euro cents anymore. And there, or even here at 44, the battery is really making you some money, yeah, from our calculations and from our real ongoing research. And we did a calculation here. What should be the tariff, and what should be, what is the buying tariff? Because in this case, I'm even considering, suppose I buy from the grid during the day, or from my next door neighbor, and sell it by storing it into the battery. And this is the difference. If you buy at 10 cents, you sell at 33. We can become like the bank. Oh, the bank is doing like, you buy and sell. So if we buy at 25, you can sell at 52, okay? Now, 52 is much lower than 70. So if I save my 70 euro cents electricity, I'm making a profit of 52 minus 70, which is quite a lot per unit. So there is a financial formula where energy storage works out. So if you have a battery, you can make some money, possibly. You can have electricity if the grid fails. So you have a number of advantages. You are independent, yeah? And the grid is there then as standby. Because can we come to that situation where I say the grid is like my battery, standby? It's possible.
Excuse me, may I ask a question now? Can I ask a question now or later?
Let me continue because it's better than I.
It depends.
No, just keep it in mind.
I was going to ask you if you took into consideration the cost of the batteries and their replacements over the years.
Yes, please come back. Yeah, good question. The difference here is replacing the battery and making 20% profit on that battery. So the difference between 52 and 70 is surplus above your 20% profit. Yes. Okay. You have to expect, for example, a lead-acid battery. For example, here in the study, it's a flooded lead-acid battery. Okay? This gives you around 800 cycles. So if you cycle it every day, you have 365 times 2, it's 2.5 years. And then you have to bring somebody to change it and so on. But if you take the trouble of putting the battery to make money, this 52 already includes the change of battery plus 20% profit for you. The difference is to become a millionaire. Okay, so the concept was this. So I came together with the researchers I have under my supervision. I'm not doing this on my own. I have very good students. We have excellent research facilities at university. Okay, and we came up, okay, let's use the word smart, because we now have smartphones, smart car, yeah? So why not we have a smart grid? We till now heard of a smart meter. But what is this smart meter? It's not smart at all, I can tell you. Okay? It just gives you what you have used. Okay? What I mean by smart is the system. Okay? So I'm generalizing there. I have a number of energy sources. I have a CHP. I will talk about it. I have PV. I can have a wind turbine. I can have a fuel cell. They are all energy storage and energy sources. And I have also the grid. And I have a smart meter which should tell me what you are going to charge me, what the grid is going to charge me, and then it's up to me to decide whether I use source 1, source 2, source n. On the other hand, you have the loads, and you need some control. Some control which we are used to today. You plug in, you buy a headphone, it's Bluetooth, you open your computer, the computer sees that you have a headphones and tells you, hello, you have a headphone, it's connected, you can start talking, okay? We can have the same technology in the house. It exists. And then a battery storage, which is there to support, okay? To support if the grid, for example, fails. I need a battery to start my PV system. Now here, I'm not talking about a PV system which you have to buy purposely with a battery, because there are different systems, okay? I will talk a little bit later. And here I said, okay, fine, you have a battery, you have your iPad, okay? And you look at your iPad, and you are not a technical person, so what you see on the screen there, hello, I'm your lead-acid horse. I am fine, and you can stop there, because for you, is the battery fine or not fine, or not okay? A lot of people are afraid of the battery because we are used to a battery in the car, and the car usually stops because the battery is not okay, okay? If till now, no car manufacturer designed a digital display or on your screen, be careful because your battery will fail in 1 month. But here in this technology, we have that. I can tell you when the battery is going to fail. There is this technology. It's not being utilized. Okay? Currently assisting the CHP or the PV. And I have 7 kilowatt hours more. So you can even from your iPad watch what is going on with your battery, so that if there is no grid and you are running out of energy, you don't switch your heater. You switch the dehumidifier, for example. Okay? There are solutions. And in order to do this, what we did is, I'm going to make an add-on on your system. Not I come to your house, you have a grid-connected PV, and I will tell you, now you know you want a battery. So I have to buy your inverter or throw away your inverter. I put you a new inverter and all this complication, which is at we speak now in the market, that is the case. So if you have a grid-connected PV system and you want a battery, and you will tell them, I want battery backup. They will tell you, but not that inverter. You have to throw away that, buy a new one, which will take a battery. No. What I'm saying here, you leave the system as is, and you buy something extra, an add-on. Okay? And this add-on is a battery with an inverter and a charger. And what happens is that the grid-connected PV system requires the grid. But if there is no grid, this will not work. What should I do to make it work? I have to create something like the grid. And to create that, I need an inverter, which switches from 48 volts to 240 volts, makes this nice oscillation that the grid does, and the grid-connected inverter will see the grid artificially through my battery. And then the grid inverter comes in. And therefore, I don't need to change anything in my existing system. And here, the display, if you want to go into details, if you have a problem, for example, we have this scenario, this red and green, yeah, to show you what is the condition of the battery. And if you are using the battery properly, if not, so that is a technical thing, which nowadays can be accessed through internet, and I can tell you from an office in Brussels what is going on with your battery in Malta. It's possible, okay? The other thing, from our analysis, we found out that, and this is what we are currently doing. I added this because some time ago I gave also a presentation, and we found out that although we don't use too much heating in Malta, but as I've shown in the previous graph, there is a very huge dip during winter. And whether one accepts it or not, in winter, yes, we need heating in Malta quite a lot, because our houses are not well insulated. Now, either we do insulation and we reduce the heating, or heat the house for those 2 months. Some tell you here it's not worth it because 2 months only, yeah, but I don't want to freeze for those 2 months, so I switch on my heater. Okay? This is an ideal solution. A CHP. What is a CHP? A CHP is a combined heat and power. And basically, if you have an engine, this is like a car engine, you have 30% effective output power. So when you drive your car, you are only using 30% of the fuel fuel content and energy content. 5 only is friction, but 25 and 40 are heat. So if I can design a system, but for Malta, for example, this system has to be small. And that's what we are designing at university, okay? That I want it for a small house. So the size of the system, which we have already built and tested, is less than the size of a washing machine, okay? Whereby I switch on this engine, okay? The power from the shaft of the engine, I turn a generator which is producing my electricity, and the heat, I heat my house, okay? And I have this dip that you could see in my energy generation during the year in my house, please. So here, for example, if I show this again, okay, I have here a problem. Actually, it's not as bad as it actually looks here, because that is the electricity demand. But in reality, I used 6 gas tanks to heat the house. Not this winter, this was the previous winter. And this is 900 kilowatt hours. 1 gas tank means 150 kilowatt hour. So 6 gas tanks means 900 kilowatt hours. And it is not shown here because this is not the electricity that I consume, this is a tank of gas. So it's even worse. And therefore, what should I do here? If I can fill here and here with some energy, some heat, and some also electricity, then I am 100% all year round. And for this, if I have a CHP, I don't need a huge battery. It can be a battery this size, okay? So if we combine, what I'm saying is that there are so many engineering possibilities to make yourself independent and comfortably at home. If the energy falling on your house or on your roof or on your island is so much, you can play around with this energy. It's a matter how to harvest it and how to store it and how to use it, okay? And here, for example, this system which we have at the university has the grid, PV, the standard PV, what you might have already in the house. This smart CHP, why I call it smart? First of all, to get attraction, your attraction, that's smart, okay? We all want to be smart, but what is smart? Smart is that it gives me what I really require, nothing extra. I don't want to use my CHP to generate in the grid. That is not effective. So I want the CHP to keep my house warm and to generate the electricity I require, which during winter is not generating from the PV. Okay, so if I have, for example, the size, we used a motorbike engine, water-cooled, a small engine, 125 cc. We use the 2 kilowatt motor, and I have 1 kilowatt. So if it switches for 6 hours during the day, I have 6 kilowatt hours, which are enough to remove this electricity dip. I need a very small battery, and the heat, I get 6 times 3, 6, 12, 18 kilowatts. With 18 kilowatts, I bring my house in an excellent, warm environment, okay? And then I need some smart loads as well. Why? Because if the PV is really performing, it's a nice winter day, and I happen to have a power cut, I want some smart loads which say, okay, I can take the energy. And I heat my water, I switch on my air conditioner, even though I'm not in the house, okay? It's a matter, it's technology, we are used to it on the mobile, but it is not coming into our house, okay? It's just a matter, wireless technology is all around us, so I don't even have to change your installation. Everything is wireless today. You plug in something in the ear or something in the car, and everything communicates. So why not the energy generators and energy consumption, okay? So as a conclusion, okay, I wanted to bring your attention a bit on what can happen in the future and what technologies are there. We have to put them together, but obviously there are challenges, okay? The use of battery, we said, is possible and is viable. I cannot tell you, everybody can put a battery. No, it has to be analyzed, and it has to be worthwhile, and it has to be viable, okay? Smart grid, everybody talks a smart grid, but we have not heard anything like this of smart grid. Okay? This is a new concept which we created, which we think is the real smartness in a grid. Whether we use grid or not, it's up to us. But my intention is, I actually want the grid to be my standby. because it might come when a situation when I don't want to use the grid. It's there, but I prefer to use my PV or my battery. Okay? So to do all this, we need to coordinate, we need to make regulations, and we need to have one scope, okay? To reduce the CO2 from this nice earth, or whatever you call it, we are on it, and important is we leave something to our next generation. That is the most important, okay? Thank you very much.